This lesson is on trig functions on the unit circle. This is section 4.3 from your book. So at this point, we're already familiar with the 6 trig functions and their trig ratios involving opposite, adjacent, and hypotenuse. And we use these in order to describe acute angles of triangles. So if you're given a triangle, some theta, you can figure out what is sine based on opposite over hypotenuse, and etc. So these trig functions can be simplified to describe any angle if we consider them on a coordinate plane. So right here we see we have a coordinate plane. We talked about theta, our angle, being the same as it's however far we rotate some vector. So for this example, we rotated some vector of length r, that's our radius also, into the third quadrant, and it creates an x and a y value at that place based on that length of r, and that helps us determine, all right, what's our sine, what's our cosine of this angle. So for this example, we have sine of theta is equal to y, whatever the y component is, divided by r, whatever that radius was. And cosine equals x, whatever the x component was of that vector, divided by r. So the unit circle is a circle with a radius of 1. Created by the equation x squared plus y squared equals 1. And this actually makes it simpler to look at some of these relationships. So when we have sine of theta equals y over r, well, if our radius is just 1, then sine of theta just equals y. So for any angle theta on the unit circle, measured from the x-axis, is an important one. We call from the x-axis our reference angles. So for any angle theta on the unit circle that we measure from the x-axis, we get the following relationships. We get cosine of theta just equals x. This is because our r just equals 1. Sine of theta is equal to y, and tangent of theta, which we know is sine over cosine, just equals y over x. So we're given this example here. We have a unit circle. We have a vector shown of some angle theta. And the way we get our cosine, well, we just look at what the x component of that is. This length right here is equal to our cosine of whatever that theta is. If we dropped this over to the y and looked at what our y component was, that would mean that our sine of theta is equal to whatever that length is. And this point on our coordinate plane might be the point x comma y. So for reference angles, we use reference angles. We talked about that briefly. Or the angle measured from the x-axis. And what I mean by that is if you have some angle, let's draw this in blue. If we have some angle here, some angle created all the way around here, then actually we're just going to use this theta right here, the measure from the x-axis, this would be the negative x-axis, for example, in order to determine some of our functions. So let's undo. And then these trig values that we find are negative or positive based on the x values and y values, whether those are positive or negative. So if we were to look at this circle again, in quadrant 1, our x and our y, if we just looked at coordinates, our x and our y are both going to be positive. In quadrant 2, if we had some point in quadrant 2, our x is negative and our y is positive in that location. And that affects our cosine of theta being positive or negative, our sine of theta being positive or negative, etc. In quadrant 3, both are negative, and in quadrant 4, we have a positive x and a negative y. So you don't have to memorize those relationships, they're just sort of things that you already understand based on coordinate planes. So we use the unit circle to determine the values of the 6 trig functions for common angle measures. To fill in the unit circle, first, we just sort of look at the top half. We're just going to look at the top half, and we're going to break that top half into 6 and 4ths. Then we're going to evaluate the x and y values for each of these angles in quadrant 1. Quadrant 1 is going to give us, because we just have a radius of 1, all of the values on the rest of our coordinate plane, on the rest of our unit circle. We just have to decide whether or not they're positive or negative and which angles match up where. Then we want to fill in the positive or negative values in the remaining quadrants. So the first thing we said that we're going to do is look at this top half, and we're going to break it into 6 and 4. So let's do this 6 first. We know that our angle here at the starting point at a positive x, we have x, that value there is just equal to 1, 0. We have a 1 for our x, and we haven't gotten any up on our y. That point is 0. Our angle is 0 right there. We have a 0. If we're going to break the rest of this into 6, that looks like this. Oops, sorry, that was supposed to be a highlighter. We want to look at this, that, our vertical axis, our y-axis, then we break the rest, 1, 2, and 3. We're going to look at these and what those different values are. So we said we're breaking this up into 6. We get pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. We know that we're going to have a 2 pi when we go all the way around, so we're just going to keep going. It's going to bring us down here to this third, or this 6, sorry, which is 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. If you want to simplify some of these, you totally can. 12 pi over 6 is obviously the same as 2 pi. 2 pi over the 6 is the same as pi over 3. 3 pi over the 6 is the same as pi over 2, which is what we expect at our 90 degrees. 4 pi over 6 is the same as 2 pi over 3. 6 pi over 6 is the same as pi, 6 pi over 6. And 8 pi over 6 is the same as 4 pi over 3. So the next thing we said we were going to do is to fill in the quarters. So let's look at our quarters that we have. If we go up to this first one, we have pi over 4. The next one we have is 2 pi over 4, but we already have that one filled in as pi over 2. Then we have 3 pi over 4. 4 pi over 4, which is pi. We've already got that one. 5 pi over 4. Then we have 6 pi over 4, which, oh, we didn't simplify that one. This is the same as 3 pi over 2. Then we go over here to our last value, and we have 7 pi over 4. We can fill in the equivalent angles. We can do it the same way. We break it up into the 6th and the 4th first, or if you just can convert these angles, or you might get familiar with them eventually. So the first quadrant is really the one to memorize, because if you have those memorized, you'll be able to move on to the rest of the unit circle. So we can fill this in as 30 degrees. This is going to be 45 degrees, 60 degrees, and 90 degrees. Now using those, you can find all of the rest of them too. Or you can convert if you forget. You have 120 degrees, 135 degrees, 150 degrees. Then we go down to 180. I should have started with 0. Sorry about that. Then we have 210, 225, 240, 270, which makes sense. 180 is halfway around, 270 is 3/4 of the way around, then we're at 300, 315, 330, and 360. So that's all we're doing here. It's not too complicated. First you're going to break it up into 6, then you're going to break it up into 4s, and you can do the same with your angles, with your degrees. So the next thing we want to do is fill in some of the other values. Some of the most obvious ones are our x and our y values at our 0, our pi over 2, our pi, and our 3 pi over 2. So those are going to be 1, 0. Obviously, we are at x equals 1, y equals 0 at 0 degrees. Up at pi over 2 degrees, we are 0 on the x, 1 on the y. At pi, we are at -1 on our x, 0 on our y. That's 180 degrees, or pi radians. And then at the bottom here, we're at 0 on our x, -1 on our y. And back up at 2 pi, we do the same, and we're going to go around and around and around. We can always add 2 pi to anything, and we're going to get these same values. We talked about that before. It's called coterminal angles. The next thing to remember is just 1, 2, 3. It's as simple as 1, 2, 3. That's how we're going to remember it. 1, 2, 3. So we're going to start with our y down here. We have square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and then we're going to come back down with the 1, 2, 3, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. If you can remember that, 1, 2, 3, you'll be able to fill in the rest of this because you'll be able to see where these angles are equivalent to each other, whether or not they're opposite or equal. Obviously, square root of 1 is just 1, so if you want to rewrite those as 1/2, you absolutely can. But remembering it as 1, 2, 3 is a pretty simple way. So if we look at our value over here, our y value at this point is the same, and our x value is just the opposite, the negative. So we can rewrite this one over here at 2 pi over 3, or the same as 120 degrees, as negative 1/2, and square root of 3 over 2. Same thing's going to happen. We're going to have square root of 2 over 2, square root of 1 over 2, and then we're just going to have the negatives of what we had before, which is negative square root of 3 over 2 here at 5 pi over 6, negative square root of 2 over 2, and negative 1/2, which I already filled in. So again, you can always just do 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Just verify that you have your values set up equivalently. I'll fill in the rest of this circle like that. And that's our whole unit circle. That's all we need to know for the unit circle. So we first just need to break it into sixths, then fourths, fill in those values, reduce them. Then we just fill in the 1, 0, 0, 1, negative 1, 0, and 0, negative 1, and then we fill in our 1, 2, 3s. And our 1, 2, 3s, if you're not sure which goes where, well, if we look right here at pi over 6, for example, we end up with the xy coordinate of square root of 3 over 2, comma, 1 over 2, or square root of 1 over 2, or 1/2. Well, which one of these is bigger? Do we expect our y to be bigger or our x to be bigger here? Our x is clearly bigger than our y at this point, and so we would expect that 3 to go with the x. If you can remember those values and you can line these up with all of the equivalent values and just remember, all right, well, here over at 11 pi over 6, my y actually needs to be negative because I'm in quadrant 4. You'll be able to do this unit circle like a breeze.